So yes, Marcos is correct. I have a new book coming out. It's called Return of the God Hypothesis. And it builds on my previous works on intelligent design. The first was Signature in the Cell. I was fortunate enough now 10 years ago to lecture on Signature in the Cell at Mackenzie University. And in fact, after the lectures I gave, Marcos and I did a debate. It was the two of us against two Darwinist professors. And the debate was in Portuguese, and I was being translated, and some of the arguments of the opposing professors went by a little fast for me to take them all in. But when we got done, Marcos said, "Don't worry, we wiped them out." So we had a lot of fun with the debate. In my book, Signature in the Cell, I argued that the information-bearing properties of DNA, the digital code that is in the DNA molecule that directs the construction of proteins and is necessary to explain the origin of the first life, provides powerful evidence for a designing mind of some kind. And many of my readers, after first reading this book and then the next book, Darwin's Doubt, said, yes, we find that persuasive, but we wonder, who do you think the designing intelligence is? And what do you think science can tell us about the identity of that designer? And I have always argued, and in the previous books argued, that that intelligent design is based on scientific evidence, and it's based on an established method of scientific reasoning, the method of that I call inference to the best explanation. But it also has larger worldview or metaphysical or even religious implications. So it's based on science, but it has implications that are friendly to theistic belief. And in my new book, I explore these implications. I attempt to address the question of the identity of the designer. As my readers ask me, who do you think the designer is? It seemed like I needed to write a book about that. And so that's what the new book is about. Now, my conclusion in Signature in the Cell, that there is evidence of design, is not obviously universally shared. And the famous Darwinist from the United Kingdom, Richard Dawkins, has made a very provocative statement that shows the other perspective very clearly. He says, the universe we observe has precisely the properties we should expect if at bottom there is no design, no purpose, no evil, no good, nothing but blind, pitiless indifference. And I've always appreciated Dawkins and some of the other new atheists, not because I agree with them, but because they do such a fine job of defining the issues. They frame the issue very clearly. And Dawkins says, since there is no design, he argues, since there is no design, no evidence of design in the natural world, there can be no designer, and therefore no evidence for any person that has godlike qualities. And he extends this idea of the universe having no evidence of design to make the conclusion that the best way to look at the scientific evidence is to conclude that there is no God. And he makes this case in his book, The God Delusion. And his argument is very simple and straightforward. He says that since Darwin's time, before Darwin, the evidence of design in nature was the most powerful argument for God's existence. But since Darwin, we know that there is no evidence of actual design, only the appearance or illusion of design. And the appearance of design can be explained away by an undirected, unguided process, namely the process of natural selection acting on random variation. And therefore, this mechanism, which functions as a kind of naturalistic designer substitute, can be allows us to explain the appearance of design without invoking a designing intelligence. And if there's no designing intelligence behind the universe, there can be no God. And therefore, he calls belief in God delusional. He says that he calls it the God delusion. He said it might still be the case that God exists, but we have absolutely no evidence of that. And therefore, it's much simpler and a more parsimonious explanation simply to eliminate the God hypothesis and to think that nature itself is self-organizing and self-creating, using, as it uses processes such as natural selection and random mutation. So that perspective, I think, is very familiar to all of us. It's since 2007, when he published the God Delusion, there have been many books by the new atheists, and the default view of scientific naturalism or scientific materialism in the universities has been around a lot longer than just 2007. So the denial of design in nature, of actual design, has led to this conclusion of materialism or naturalism, and indeed a form of scientific atheism. Now, what I love about Dawkins's statement here is that he suggests, however much we might be convinced of materialism as the best worldview, that our worldviews are actually testable against observations. Because he says here, the universe we observe has precisely the properties we should expect. If there were no design, no purpose, nothing but blind, pitiless indifference. But what I want to ask, and what I do ask in my new book, is that actually true? Does the universe have those properties that we should expect if materialism or atheism were true? Or does it instead have properties that we should expect if theism were true, or if the theory of intelligent design were true? So Dawkins implies here that what we see in the universe can actually help us adjudicate the questions of the ultimate questions, the ultimate worldview questions. So let's see, and this is what I'm going to do in this lecture. Let's see what the properties of the universe actually do have to tell us about whether materialism / atheism on the one hand, or theism on the other, is more likely to be true. Now, obviously, Dawkins's perspective here is very different than the perspective of, say, the biblical writers, who long held that there was something about nature, the properties of nature, they said, declared the glory of God. The heavens declared the glory of God, as the psalmist put it. And in Romans 1, there was discussion of the powers of God, and his divine nature were clearly seen, being understood from what has been made. So the biblical perspective is quite different than the Dawkins perspective, and obviously so. But it's interesting that both the biblical writers and Dawkins assume that there's something about nature that can answer this big question about whether God exists or not. Now, what might surprise you, it isn't too surprising, I suppose, that these biblical writers disagree with Richard Dawkins and vice versa. But what might surprise you is that the founders of modern science also had a profoundly different view of the relationship between science and faith than do the modern new atheists. This is a front piece from or title page from one of the early works of modern biology, written in the 17th century by John Ray. He said his title here is "The Wisdom of God Manifested in the Works of Creation." And it actually is it's a paraphrase of this passage from Romans, where it says, "Since the creation of the world, God's invisible qualities, his eternal power and divine nature, have been clearly seen, being understood from what has been made." The words we translate divine nature are translated in the older Bibles as divine wisdom. So the wisdom of God manifested in the works of creation. Now, this is one of the early works of biology, or in the period of early modern science, this is one of the great works of biology. Now, you also find this with the astronomers. For example, Johannes Kepler thought that in mapping the mathematical harmony of the planetary orbits, that he was having the opportunity to, as he put it, think God's thoughts after him. He he was convinced that the intelligibility of nature that made science possible was a consequence of nature having been made by an intelligent mind, by the mind of God. And many of the scientists during this period actually thought that science, their inspiration for doing science was their assumption that nature would manifest a discernible order, that it had an intelligible order, that we human beings made in God's image, with minds that had been made by God to understand the rationality that God had built into the world, that correspondence between the rationality of the cosmos and this natural world around us and the rationality that God built into our minds made us capable of doing science. We see a similar idea with Robert Boyle, who thinks of the natural world as a great designed mechanism. He said it's like a rare clock where all things are so skillfully contrived that once the engine being once set moving, all things proceed in accord with the artificer's design. And this idea that nature is displaying evidence of design, that the order in nature is the result of a divine lawgiver, was part of the inspiration for modern science. And it reached an almost, this perspective reached an almost majestic quality in the works of Sir Isaac Newton. He not only presumed, as many of the early modern scientists did, that nature would exhibit a regular order that was an expression of the divine mind. He believed that he could see evidence of that as well. And so he made arguments for design in his works. First, in both the optics, which was his great work in physics, he saw evidence of design in the way in which the physiology of the eye seemed to anticipate the properties of light. But also in his great work on gravitation, the Principia. This is from the General Scholium to the Principia. It's an epilogue that he added in the second edition or third edition. And here he says, he's talking about basically the fine-tuning of the solar system, and how each of the planetary bodies with their different gravitational forces just balance each other perfectly, such that the stability of the solar system results. And here's what he says about this. He says, though these bodies may indeed continue in their orbits by the mere laws of gravity, yet they could be by no means have first derived the regular position of those orbits themselves from those laws. Thus, this most beautiful system of the sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being, capital B. So here he's making an argument for design based on the exquisite fine-tuning of the solar system, that everything seems to be delicately and perfectly balanced to maintain the stability of the system. So this is a very different perspective, obviously, than the perspective of the new atheists. And it really raises a question: how did we get from Kepler and Boyle and Newton and the other founders of modern science, with their overtly theistic perspective on what the natural world was revealing, to the modern new atheists? Well, there's a long story, and I tell much of this in my book, Return of the God Hypothesis, because if we're saying that the hypothesis of God is returning because of modern scientific discoveries, that implies that that perspective was lost, and it also implies that before that there was a theistic perspective that guided modern science. Well, the story of reversal begins in the 19th century, when many scientists began to adopt a more naturalistic approach to science. And one of the first was Pierre Laplace, the great French physicist. He wrote a book in 1796 called The Celestial Mechanics. And he attempted to do exactly what Newton said you couldn't do. Newton had said that you couldn't explain you could explain the regular motions of the planets by the laws, but you couldn't explain their initial condition, their initial positioning. But Laplace attempted to do just that, to explain the origin of the solar system itself by reference to the law of gravity alone. And in 1802, he was summoned to the Palace of Versailles by the Emperor Napoleon. And the purpose of the visit was for Napoleon to commend Laplace for having written this great work of science. But Napoleon himself was curious about why Laplace had seemed to reject Newton's approach to science, and he asked him, "Why is there no mention of God in your book?" And in Newton's work, he mentions God frequently, and Laplace is said to have answered, "Sire, I have no need of that hypothesis." Now, we're not exactly sure if he said those particular words. The first account of this conversation came 20 or so years later, and historians think it could be apocryphal. But what's not in doubt is that Laplace certainly did adopt this very strictly naturalistic approach to explanation, even the explanation of the origin of the solar system. And that approach caught on through the rest of the 19th century. In geology, soon people were explaining, geologists like Lyell and others were trying to explain the origin of the mountains and the canyons and the great geological features on Earth as a result of slow, natural, gradual processes. And of course, in the work of Darwin, we have the explanation of the appearance of design as the result of a purposeless and unguided process. In one of our leading college level, university level biology texts here in the United States, Douglas Fatuma, one of the leading evolutionary biologists, puts it this way. He says, by coupling the undirected, purposeless variations to the blind, uncaring process of natural selection, Darwin made theological explanations of life superfluous, unnecessary. He had no need of the God hypothesis, or indeed even a more basic design hypothesis. Everything could be explained by unguided, undirected processes. And in the immediate wake of Darwin's work, other scientists extended this view. Darwin didn't attempt to explain the origin of the first life, but within a decade or so, there were other works by Thomas Huxley and the German evolutionary biologist Ernst Haeckel that attempt to explain the very first cell as the process of undirected chemical, as the product of undirected chemical reactions. And so by the end of the 19th century, there was a kind of seamless account of where everything had come from, all the way back to the origin of the solar system, the origin of the great features on planet Earth, the origin of the first life, the origin of new forms of life. And in Darwin's work, the descent of man, he extended his own theory to explain not just the origin of other species, but the origin of our species as well. And so by the end of the 19th century, you had this kind of seamless materialistic account of the origin of all things from the dawn of the solar system right to the origin of human beings ourselves. And that gave rise not only to a different approach to the origins question, but to a dominant worldview, one that scholars now call scientific materialism because it is allegedly based on science. And we sometimes explain materialism as a worldview by contrast to the biblical idea that you find in, for example, the prologue of the book of John, where the biblical writer says that in the beginning was the Word, that the universe issued from the mind of the Creator, and there was a beginning to it. The physical world had a beginning. Materialism asserts the opposite, and one way to think of it is to kind of invert that biblical phraseology. And one colleague of mine has put it this way. He says, from the eternity, the materialists say that there wasn't a beginning, but rather from eternity past, there were the particles and the energy. And the particles and energy arranged themselves and became complex living stuff. And the living stuff evolved by Darwinian processes, producing all kinds of new forms of life. And one of those forms of life, one of those parts of the living stuff, eventually became aware and self-conscious. That would be us human beings. And the living stuff then conceived of God, conceived of the idea of God. And so you have, in the materialistic worldview, you do have the concept of God, but God only existing as a concept in the mind of human beings. And if you've had any psychology or history of psychology, this idea will seem reminiscent to you, because this was Freud's idea, that God did not create man, but rather man created the concept or the idea of God. It's a great reversal. And so by the end of the 19th century, this materialistic worldview becomes to predominate the thinking of intellectuals, especially in the West. And you have Darwin, who tells us where everything came from. You have Marx, who has a materialistic vision of the future and where we're going. You have Freud, who tells us what to do about our guilt. And between these three great thinkers and others, science or scientific materialism seems to address many of the fundamental questions that a theistic or Judeo-Christian worldview had always addressed in the past. So there's a very profound intellectual shift that it begins by the end of the 19th century. Of course, it has deeper roots back into Enlightenment philosophy in the 18th and previous centuries. Now, that's kind of where we are today in the sense of the dominant worldview in many of the universities. And this has come out of the late 19th century. But the story of my book is a story of a great reversal, the return of an earlier perspective as the result of three great discoveries that have been made in modern science, in contemporary science, since the 20th century, over the last 100 years. And the first of those discoveries, here I have a little diagram of materialism that I used to use when I was teaching with students to get across the concept of this grand synthesizing worldview. The disk represents the physical world. The pendulum represents the laws of nature. That we're being moved by the laws of nature represents the idea that we're completely determined by them. And the Michelangelo picture of God with the X through it indicates that in the materialistic or naturalistic worldview, all that fundamentally exists is nature, that matter and energy are the prime realities from which everything else comes. And if you've done any study of the concept of worldview, a worldview is a kind of comprehensive philosophy that many people are unaware they have a worldview, but all worldviews do have to answer most fundamentally this question of the prime reality. What is the thing or the entity or the process from which everything else comes? And in materialism, the answer to that question is, of course, matter and energy. And matter and energy are eternal and self-existent and self-creating and self-organizing, and therefore they form the basis of everything. They're the foundational realities from which everything else comes. Now, the story of my book is the story of the challenge to this worldview on the basis of three great discoveries. And the first of these discoveries is made in the field of astronomy and what we now call as well cosmology, the study of the universe as a whole. And much of the credit for this discovery has gone to a man named Edwin Hubble, an astronomer. He was who worked in Southern California at the Mount Wilson Observatory. He came into astronomy from law. He was a lawyer, but he joined the field, the astronomical profession, at a very propitious time. In the 1920s, the astronomers were just beginning to build these great domed telescopes. And as a result of using these great telescopes, Hubble was able to observe the distant points of light in the night sky with a precision that astronomers had never been able to achieve before. In addition to these big telescopes, astronomers were beginning to use photographic plates to collect a great deal of light over a long exposure. And as a result of that, they were able to resolve images in the night sky with greater precision than ever before. So, for example, these are some of Hubble's original photographic plates. This is a spindle nebula. In the night sky up until the 1920s, astronomers didn't really talk about galaxies. They talked about nebula. They were points of light, and they could see that they had some fuzzy structure to them, but many thought that they were just gaseous accumulations within our Milky Way galaxy. But as Hubble was able to resolve these images with these, with the use of photographic plates and with these giant telescopes that were collecting much more light than ever before, he became convinced that they were actually galaxies in their own right. That they were clusters of hundreds of possibly millions of stars on their own. This is a spiral nebula. And then in 1923, 1924, he was able to determine the distance to a famous nebula called the Andromeda Nebula, which we now call the Andromeda Galaxy. And using some new techniques that had been developed for measuring distances, Hubble was able to determine that the distance to the Andromeda Nebula was greater than the entire distance across the Milky Way. And therefore, he was able to determine for sure that these different nebula that he had been photographing or through his telescope were in fact galaxies beyond our own. And that was the first big discovery that he made, that our galaxy, the Milky Way, is not the only galaxy. Up until 1920, there had been a big debate about that among astronomers. So we've only known of other galaxies for less than 100 years. But the next big discovery that he made was that these galaxies were vast in the night sky. And as he looked in every direction, there were galaxies galore. And now when we look at what's called the Hubble Deep Field, we're really amazed at the vastness of the universe. If you keep your eye on the little square on my screen there, you can see that there are several interesting points of light within that square. And if that's amplified, we get what's called a picture of the Hubble Deep Field. And you see that there are galaxies even in these tiny little quadrants of the sky. As you magnify them, there are an immense number of galaxies, even in the tiniest little quadrant of the night sky as we look out. And this has given us the awareness that not only are we not alone as far as the existence of other galaxies, but that the current estimate is there are about 200 billion such galaxies in the universe. And so the second thing that Hubble discovered was the vastness of the universe, that it was just extraordinarily large. But then he discovered something that is arguably even more significant from a theoretical or even philosophical point of view. And what he discovered was that the galaxies are each moving away from us. That as we look at the galaxies in the night sky, we find, as your previous speaker was discussing, that the light coming from those galaxies is redder than it should otherwise look if the galaxies were stationary. The spectral lines on the light that we perceive has been shifted in the red direction of the electromagnetic spectrum. Now, if you're familiar with light spectra, you know that if you shine light through a prism, it will separate into different colors from red to violet. And red light corresponds to the electromagnetic radiation that has a longer wavelength. And this is, light gets a longer wavelength if the source of the light is moving away from it, because as the source moves away, the light stretches out. Many of you will be familiar with the Doppler effect, what happens if say a moving train with a whistle on the train moves away. We'll hear the pitch of the whistle, it will drop. And that is also the result of the sound waves stretching out as the object moves away. And we have a similar phenomenon with light. And so the discovery that light, the spectral lines indicating the frequency of the light for different elements coming from those distant galaxies was being shifted in the red direction. It was stretching out, suggested that those objects in the night sky were moving away from us. And if the objects in the night sky are moving away from us in every direction, that suggests something very, very significant. In fact, there was one other thing that Hubble discovered about this, and that is that the further objects were away, the further the galaxies were away from us, the faster they were moving away. The farther, the faster. The farther, the faster was his law. And you can see that graphed on the side of my slide here. Now that relationship between distance and recessional velocity, that linear relationship, suggested that the universe itself was expanding outward, that if every galaxy is moving away from every other galaxy, and if the ones that are further away are moving away the fastest, then that suggests an expanding universe, and a universe that's expanding like a balloon. And I have a little visual aid. I hope it comes across in the Zoom here. So if the galaxies, which I've drawn on the balloon, are each moving away from us and from each other in the forward direction of time, that suggests that the universe is getting bigger and bigger and bigger in the forward direction, that space and time itself is expanding, carrying the galaxies apart from us. So this is known as the expanding universe. But what you can also think about then is the universe is expanding in the forward direction of time. That suggests something about the universe in the distant past. Because if we back extrapolate, if we run the video backwards, if we can see in our mind's eye the universe going forward, galaxies getting bigger and bigger and further away. If we rewind the time back in our mind's eye, we see that the galaxies will be getting closer and closer and closer and closer together till finally they all converge on the same point, a point that would mark the beginning of the expansion and arguably the beginning of the universe itself. And that is a profound conclusion, that the universe itself may well have a beginning. Now, oddly, that conclusion was anticipated by a famous physicist with terribly bad hair, someone we all recognize, an iconic figure in 20th century science, Albert Einstein. Einstein in the 19-teens had developed a new theory of gravity known as general relativity. And according to his theory, massive bodies actually bend or curve space, or what he called space-time, such that if gravity were the only force in the universe, then space itself would be curving up on itself to form a black hole. And that led him to realize that gravity could not be the only force in the universe, that there must be something pushing against gravity. And that suggested that the universe was dynamic, that it would have had a beginning. If something was pushing outward to create the space that we now see between galaxies and planets and stars, then that outward push could have started from a beginning. It likely would have started from a beginning to create the space that we now see. But Einstein didn't like the idea of a beginning for philosophical reasons. At this point in his career, he was a committed scientific materialist. And so what he did say, what he proposed was that outward pushing force, which he called the cosmological constant, was precisely balanced against gravity so that the outward push and the inward push of gravity were equal. And therefore he was able to depict the universe as a steady state, as a kind of an eternally existent, balanced universe between the outward push and the inward push, with no beginning and no end. His theory, taken at face value, implied a dynamic universe, one which was changing from a beginning. But he fiddled with this value of the cosmological constant to eliminate that implication. But oddly and unexpectedly, the heavens talked back. And in 1929, Einstein learned about Hubble's discovery of the red shift from another astronomer named Arthur Eddington. He'd also learned about it, I think maybe 2 years earlier, from a Belgian priest who was a physicist named Georges Lemaitre. And so Einstein realized that he began to realize that the evidence was against his idea of a static universe. And he went out to California, met with Hubble. And there's some famous newsreel footage of the 1930s where Einstein is looking through the telescope with Hubble. And a month later, he gives an interview with the New York Times. and acknowledges that the universe is not static, that Hubble and his colleagues have shown that the universe is dynamic, that it's expanding, and that it is expanding from a beginning that marks the beginning of the universe. Now, this later became known as the Big Bang Theory. And we're indebted to this Belgian priest named Lemaitre, who showed that Einstein's equations describing general relativity and the evidence from observational astronomy together suggested most naturally the idea that the universe had a definite beginning. Now, many physicists didn't like this because they realized that it had philosophical implications that challenged many of their deeply held assumptions. This is a quotation from Sir Arthur Eddington, one of the great British astrophysicists at the time. He said, "Philosophically, the notion of a beginning of the present order is repugnant to me. I should like to find a genuine loophole. I simply do not believe the present order of things started off with a bang. The expanding universe is preposterous. It leaves me cold," he said. Now, in psychology, there's a name for this theory. It's called denial. You can see that Eddington is not offering any scientific evidence against the idea of a beginning. He just says that philosophically he finds it distasteful, and many scientists did. But by the end of the 20th century, so many additional evidences of the beginning, evidences that supported the Big Bang Theory, had come online that most scientists had come to accept that the universe definitely has a beginning. And one of the Princeton physicists in the 1960s, Robert Dicke, explained why this was so unsettling to many physicists. He said, "An infinitely old universe would, quote, relieve us of the necessity of understanding the origin of matter at any finite time in the past. If the universe has always been here, we don't have to think about what caused it to come into existence. But if it had a definite beginning, if matter and energy come into existence, then we can't invoke matter or any material cause as the source of the universe, because there's no matter before the universe to cause the matter to come into existence. There's no matter to do the causing, if you will." So the Big Bang Theory poses a profound challenge to the idea of materialism, the philosophical view that the universe has always been here, the material universe has always been here, because we now have a very strong indicator that it hasn't. Now, the indication of the beginning that came from this observational astronomy gained even greater support in theoretical physics because of work that was done in the 1960s by Stephen Hawking, Roger Penrose, and George Ellis, three physicists who were working in Cambridge and Oxford. Hawking first came up with this in his 1964 PhD dissertation. He was working on black holes and realized that a black hole is a place where gravity is so intense that not even light can get out, where you have a curvature of space then that's so tight that not even light can get out. But as he applied that idea to thinking about the origin of the universe, he realized that as you go back in time, that the universe would have been getting smaller and smaller and smaller, and therefore the density of matter would have been getting more and more compact. The curvature of space would have been getting tighter and tighter, and eventually, as the matter is curving the space, it gets to a place where the curvature of space becomes infinitely tight, that there's a limiting case where eventually someplace in the finite past, the curvature of space becomes so tight that it corresponds to zero spatial volume, what's called the singularity. And that there was also at that point a beginning to time, because in Einstein's theory, time and space are connected. And so you have this result, it's called the singularity theorem, coming out of theoretical physics that suggests very powerfully, again, that the universe had a beginning, that even space and time had a beginning. And this is another powerful challenge to materialism, because if you ask yourself the question, how much matter can you put in zero spatial volume? Of course, the answer is none. No stuff can fit in no space. There's some other additional things that we can talk about maybe in the Q&A that reinforce this idea, that the universe had a beginning, things that have come out of theoretical physics, a famous theorem called the Borde-Guth-Vilenkin theorem. So astronomers throughout, beginning in the 1980s and 90s, began to realize that these new developments in cosmology had profound metaphysical implications. When I was a young scientist, I encountered a talk by Alan Sandage from Caltech, who was one of Hubble's successors in the observatory there. And he said that speaking of the Big Bang and the evidence from theoretical physics, he said, here's evidence for what can only be described as a supernatural event. There's no way that this could have been predicted within the realm of physics as we know it. And this discovery that the universe had a beginning has revived an ancient argument called the cosmological argument that goes like this: everything that begins to exist must have a cause. The universe began to exist, therefore the universe itself must have a cause separate from itself. And as theologians have said, we think of that cause separate from itself as a transcendent cause. We call that cause God. And of course, there's a connection here even to the biblical idea that the first idea in the Bible, that there was a beginning. In the beginning, God created the heavens and the earth. So this is a dramatic scientific discovery, and that has produced an equally dramatic shift in perspective. This has challenged materialism, and it seems to be supporting a kind of theistic interpretation where some transcendent cause must be invoked to explain the origin of the universe itself. In fact, one of the scientists who played a huge role in confirming the Big Bang theory, Arno Penzias, who discovered what's known as the cosmic background radiation, has said that the best data we have concerning the Big Bang are exactly what I would have predicted or expected had I nothing to go on but the 5 books of Moses, the Psalms, and the Bible as a whole. Now, when I saw this quote, I thought this language was very interesting. The way he phrased this was very interesting because, of course, we started the lecture by talking about what we would expect if materialism were true, if there was nothing but blind, pitiless indifference and no design or purpose. And the physicists are saying, actually, what the data we have is what we would have expected if a theistic or biblical view of the world were true. There's a beginning. This is not something that's expected on the basis of scientific materialism. Materialism expects that the universe would be eternal and self-existent, that it would have no beginning. So a first test of Dawkins' idea, of his proposal for evaluating materialism versus theism, is a test that materialism fails to meet. Materialism expects no beginning, no evidence of a beginning, but instead modern astronomy, physics, and cosmology has suggested the opposite. There was a beginning. That's an unexpected result for scientific materialists. Now, a second result that's come out of physics, a second discovery that's also unexpected from a materialistic point of view, is the discovery of what's known as the fine-tuning of the laws and the constants of physics and of the initial conditions of the universe. You can think of the fine-tuning, and physicists often describe it this way, as, first of all, a set of parameters, a set of physical parameters that are required to be set just right to allow for life in the universe. Physicists tell us we live in a kind of Goldilocks universe where the fundamental forces are not too strong, not too weak, where the balance between them is just right, where the speed of light is not too fast, not too slow, the age of the universe is not too old, not too young. Everything is just right to allow for the possibility of life in the universe. And one physicist, a British physicist from Cambridge, Sir John Polkinghorne, has attempted to depict the idea of the fine-tuning with what he calls a universe-creating machine. He asks you to imagine in your mind's eye that there's a control room at some, maybe some space station someplace that has all of the dials for setting the fundamental parameters of physics. And each one of the dials is set to a very precise value. The values could be otherwise. They could be larger or smaller, but they are set just right to allow for the possibility of life. And Polkinghorne, when he uses this illustration, he asks his audience, well, what should we make of this? And he said in his British understatement, well, I don't say that the atheists are stupid. but I do say that theism provides a more satisfying explanation. This fine-tuning suggests a fine-tuner. And one of the scientists who first discovered the fine-tuning, another Cambridge physicist named Sir Fred Hoyle, put it this way. He said, a common sense interpretation of the data suggests that a super intellect has monkeyed with physics as well as chemistry and biology. Fine-tuning suggests a fine-tuner. One of the most intuitive examples of fine-tuning, and just to get your mind around this, is we think of that expansion rate of the universe. And one of the factors that generates that expansion is this cosmological constant. And the cosmological constant is said to be fine-tuned to at least 1 part in 10 to the 90th power. And to put your mind around how exquisite that fine-tuning is, realize there are only 10 to the 80th elementary particles in the universe. So that would be like looking for, it'd be the odds of getting the cosmological constant just right to make life possible would be like finding 1 marked elementary particle in 10, looking for it in 10 billion galaxies. It's incredibly improbable to get the balance just right to make a life-friendly universe. The universe expands too fast, we'll get what physicists call a heat death. If it expands too slow, the universe will recollapse and form what's called the Big Crunch. So all these different parameters, expansion rate, strength of gravity, strength of all the different fundamental forces are balanced just right. And Hoyle and many other physicists have suggested that this points to a super intellect, to intelligent design of the universe as a whole. So that's the second big discovery. Some of you will know that some materialists have attempted to explain that on the basis of something they call the multiverse, that there are gabillions of other universes out there, and we just happen to be the lucky one where all the parameters worked out just right. We can talk about that more in the Q&A. I address that challenge head on in my book. A short answer to it is that it turns out that to get a multiverse, you have to have a universe generating mechanism. And that universe generating mechanism in all models that have been proposed itself requires exquisite fine tuning. So even the multiverse doesn't get around the fine tuning problem, but we can just discuss that more. Now, the final discovery, the third big discovery, is the evidence of design in biology, especially at the macro or at the molecular level. Many of you are aware of the work that our colleague Michael Behe has done on the tiny miniature machines that are inside cells. He has a very compelling argument for design that he's made about what he calls the irreducible complexity of these molecular machines. I won't reprise that argument here, but I want to point out, use those little molecular machines to illustrate an even more fundamental evidence of design. If you think of this, this is Behe made famous this bacterial flagellar motor. And these tiny machines inside cells are made of proteins. One of the proteins in this flagellar motor is a hook protein. The flagellar motor itself has a rotor, a stator, bushings, O-rings, and a drive shaft. It looks for all the world like something that one of the car companies might design. It's a beautiful rotary engine. But keep your eye on that hook protein, and you see that that protein is made of smaller subunits called amino acids. And we now know that in all proteins, whether they're functioning as structural parts of molecular machines or enzymes or large molecular complexes that process information, whatever the job the protein does, it does that job on the basis of a very specific three-dimensional shape. And that shape is produced by the specific arrangement of amino acids that cause the protein to fold into a specific structure. And that has raised the question in molecular biology of how do those amino acids get sequenced properly? And that was discovered in the 1950s and 60s as a result of the work of Watson and Crick and many other molecular biologists who realized that the proteins were produced by the information stored on another large bio-macro molecule called DNA. That was their famous discovery. 1953, Watson and Crick discovered the structure of the DNA molecule. In 1957, Crick puts forward an even more profound hypothesis called the sequence hypothesis, in which he proposes that the arrangement of the chemical subunits in the DNA molecule are functioning like a digital code, or functioning like alphabetic letters in a section of text. That is to say that the arrangement of those characters is determining is directing the synthesis of the proteins. And so that what you have going on inside the cell is you literally have information in an alphabetic or digital form that is directing the construction of the critical protein parts of the cell. Our local hero here in the Seattle area in the United States, Bill Gates, has said that DNA is like a computer program, but far more advanced than any we've ever created. And so if you're familiar with my argument from signature in the cell, you know that I think the presence of information is extremely significant. To build the first life, you have to have information. You have to have it in this digital form. And that raises the question, where did that information come from? And what we know from experience, from our uniform and repeated experience, is that information always arises from an intelligent source. There's a principle in the historical sciences that was very important to Darwin. And he got it from his mentor, Charles Lyell. And that is, the principle is this: if you're trying to explain an event in the remote past, you need to explain it by reference to causes now in operation, causes that we see at work today. And I first came across this idea in my PhD work when I was working on the methodological rules or the methodological procedures of the historical sciences and how that applied to origin of life questions. And looking at I was reading about how do historical scientists determine what caused things in the past. And I came across this passage from Lyell where he says that the key, if we want to explain something in the present, is to find a cause that's now in operation. And so I began to ask myself the question, what is the cause that's now in operation for the production of information, for the production of digital code? What produces information? What do we see in the present that causes information? And as I was thinking about that, I came across this passage in an early work on information theory and how it applies to molecular biology. And this famous biophysicist, Henry Quastler, said the creation of new information is habitually associated with conscious activity. That's what we know from our uniform and repeated experience, to use Lyell's phrase. So if that's the case, then what is the best explanation for the origin of information? Well, the best explanation would be the one that invokes a cause now in operation, a cause that's working today. And in fact, when we think about the origin of information, whether we're thinking about it in a digital computer form, or whether we see it in a hieroglyphic inscription, or whether we see information in a paragraph in a book, whenever we see information and we trace it back to its source, especially if it's in a digital or alphabetic form, we always come to a mind, not a material process. So in Signature in the Cell, I argued that the best explanation for the origin of the information necessary to produce the first life was in fact a mind, an intelligent agent. And so I go into a lot more detail in that book, of course, also showing why other explanations for the origin of information fail. But at the end of the day, I think we've now had three big discoveries, and this is what I discuss in the new book, three big discoveries that we have to reckon with. The first is that the physical or material universe had a beginning. The second is that the universe has been fine-tuned from the beginning, it's been fine-tuned for life from the beginning of the universe. And thirdly, that we have evidence of intelligent design in life in the infusions of information that have come into our biosphere since the beginning. We need information to build the first life. We need new information to build new forms of life. And if information is an indicator of intelligent activity, then we have a profound indicator of an active creator in building life. So what I've done in the new book is I've applied this method of multiple competing hypotheses or inference to the best explanation, not just to evaluate competing scientific theories, but to evaluate competing worldview hypotheses with respect to these three big discoveries. And what I show, the Big Bang, the fine-tuning, and the evidence of information in DNA. And I show that of these great worldview systems, only theism can explain all three of these. Materialism doesn't explain the origin of the universe, the material universe. It doesn't explain the origin of the fine-tuning because the fine-tuning requires a mind, a fine-tuner, and materialism denies that there's any mind before the universe. And materialism also fails to explain the origin of the information that's needed to build life. And that's the case I make in Signature in the Cell and Darwin's Tao. Pantheism, another worldview, and the Eastern worldview, that says that matter and energy, the material world, is coextensive with God, that God is in the matter is in God, that God is in the universe, that the universe is God. That worldview also fails to explain the beginning of the universe for the same reason that materialism does. Because before the material universe exists, there would be no God. God and the material universe are one and the same. They're coextensive, is the philosophical term. And also, pantheism denies the existence of a mind. The God of pantheism is a mindless, mystical force. It's not an intellect or a person to whom you could, or with whom you could communicate. And so there is no mind prior to the universe to explain its fine-tuning. And therefore, pantheism also has a hard time explaining the origin of information, because again, we know from experience that information always comes from a mind. Deism can explain the origin of the universe and its fine-tuning, but it doesn't do a good job of explaining the infusions of information that come into the universe after the beginning, giving evidence of design at that point, because the deistic God only acts at the beginning of the universe by definition. And some have proposed that, well, maybe the evidence of design we see in biology is the result of some imminent intelligence, a space alien or some kind of intelligent agent out and living in some other galaxy or planet. This has actually been proposed by no less a scientist than Francis Crick. Right? Richard Dawkins floated this idea at the end of a film called Expelled. But this hypothesis might in principle explain the origin of the information in life on our planet, but it wouldn't explain the origin of the information necessary to build the alien, nor would it explain the origin of the fine-tuning of the universe or the universe itself upon which its very existence would depend. So the panspermia idea also fails to explain these three key evidences that we've looked at. Instead, the only worldview that explains all three of these evidences is theism, the idea of a transcendent intelligence that can explain the origin of the universe, that could act to cause the universe because it transcends the universe, and a transcendent intelligence that could fine-tune the laws of physics to make life possible, but also an intelligent agent that acts in the creation after the beginning of the universe that could account for the infusions or bursts of information that we see arising after the beginning. So that's the worldview that posits a God that acts in all those ways is the worldview known as theism, the worldview that is actually affirmed by the Judeo-Christian tradition. So there are a number of people who are seeing that this God hypothesis has more plausibility than ever before. One is an historian of science named Frederick Burnham, who says that the idea that God created the universe is a more respectable hypothesis today than at any time in the last 100 years. In my new book, Return of the God Hypothesis, I argue that it's not only more respectable, but that it provides the best overall explanation of the great discoveries that have been made in the last century about biological and cosmological origins. And I call that, therefore, the return of the God hypothesis. And I'll stop here and take questions. Thank you very much.